Hello everyone, welcome back to the channel. So today's LeetCode question 1871 Jump Game 7. It is a medium level question and it has been asked in Google and Amazon. Let's go through the problem statement. So we have been given a string s and min and max, and what we have been told is from any index I you can jump to any index j which is within this range, I plus minimum jumps and I plus max of jumps, and the jump is possible only when the value at index j is equal to 0. Now what we have to do is we had start at the 0th index and we need to return a true or false on the basis of this. If you reach the end index, you return a true. If you are not able to reach the index, any index, return a false. Okay, consider this. So from any index we can go to multiple indices which are in front of it, right? So consider if we consider each index as a node and the range gives us the direction of the edges, so we can create a graph like structure like this. Okay, for this example, like we have been told that minimum jumps equal to 2 and max jump equal to 3. We start at the 0th index. From 0 we can go to these two positions. Okay, so we can jump here and here, but this is one only, so we can just jump to here. So we create an edge like this. We create all the nodes like this, and this is the first edge. Now from this index we can jump to like in within this range. The index is 3, minimum jumps is 2, so 3 plus 2, and max jump is 3. 3 plus 3, so 5 to 6 we can jump. So if you stand at index 3, you can jump to the fifth index which is 0. You can find, and like 6 will be out of bound. So this is the graph which we can create. So the question becomes, in this graph from the starting index, can you reach the end index? Now this is the path traversal problem. So either we can use a BFS solution or we can use a DFS solution. Now BFS solution gives us the shortest path to any index. So let's use this. Okay, when you are doing DFS, the directions are important and we can calculate directions from this. So when you are starting at index I, you can like iterate within this range, I plus minimum jumps and I plus maximum jumps. I have taken the basic BFS setup here. The queue, add 0 to the initial index, the visited, make the initial index as true. Okay. Then while queue is not empty, just poll the things and check if you have reached the final destination. Then return true. Then you iterate through all the directions we discussed. For I equal to current plus minimum jumps, I is less than equal to current plus maximum jumps, and I should be less than equal to n minus 1. We can go out of the index, out of bound, right? And I plus plus. So if s of like the character at the I is 0 and the visited is false, that this particular index is not visited, just add to queue and visit again. So this iteration will like happen, and if you see that you have reached the end, return a true or else return a false. Let's go through the dry run. So initially queue have 0 and the visited as 0, and the range forms as from 0 forms as 0 plus 2 is 2 and 0 plus 3 is 3. So we can iterate in this 2. Okay, so here 1 is of no use, like we can't reach 1 because we have been told that only 0 value we can reach. So from 0 we reach 3, so we add 3 to the queue and make it as visited. So from 3 we can have the range of 5 to 6, 3 plus 2 and 3 plus 3. So from 3 we can reach to 5 and we can go beyond 5. So like we can just reach 5, so we add that to the queue and make it as visited. Now the range for it becomes 7 and 8, but when you poll this, you have see you reach the end, so return it true. Okay, consider this. We were praying in a very small range. What if the range is too big? When current equal to 0 and the range comes like 2 to 1000. Okay, then you add 2 to the queue. When current equal to 2, the range comes as 3 to 1001. You add 3 to the queue. Current equal to 3, scan from 4 to 1002. Now this is a bigger range, right? And one more thing, like we are doing the same operations again, like 2 to 1000 have something overlapping with 3 to 1000, 1001, right? So when you scan for this range 2 to 1000, you are also scanning from 3 to 1000, right? And from 3 to 1001, this is also again being computed, right? So like when you will solve using this solution, the directions we discussed, you will get a time limit accelerator because you are scanning the same elements again and again. So 2 to 1000 have scanned the this range like 3 to 1000, and like 3 to 1001 will have scanned 4 to 1001, right? So this will give TLE. Okay, how to solve this is we can keep a furthest variable. So what this furthest variable will have is maximum length that it has reached. So when current equal to 0, we were scanning from 2 to 1000. So the furthest distance it have calculated is 1000, right? So no need to calculate the range from 2 to 1000 again, right? We can go after this. We can find a solution after this. So when you are scanning for current equal to 2, in the range the current equal to 2, the range was 3 to 1001. No need to calculate for 3 to 1000, you have already calculated previously. Okay, calculate for 1001 only. So this thing, when current equal to 3, we were scanning from 4 to 1002, right? But if you see 4 to 1000, 2 to 3 to 1000 was scanned here only, and the 1001 guy was scanned here. So just calculate for 1002. So for the directions code, do just this thing, start your iteration from the start index, which will be current plus minimum jumps, a maximum of current plus minimum jumps, and the farthest, and end will be minimum of current plus max and n minus 1, and at the end update farthest as equal to end. The code will be in the comment section. Do code this out. If we don't keep the furthest variable, look here, we will just recomputing the ranges again and again. There is an overlap between all the ranges, so the solution was becoming order of n square. With the furthest, if we have the furthest variable, the solution becomes order of n. So this overlapping recalculation will be stopped. Okay, that's it for this problem. Thanks for watching. If you want more content on LLD, HLD, Gen AI, DSA and software engineering projects, do consider subscribing us. Thank you.